Where are the primary school teachers? Please come closer. I want you to supervise as I explain intuitively how I believe 4 divided by 2 over 3 should be taught across these 4 classes, 3 down to 6. I'm only inviting you because I have never been to primary school as a teacher. This is just based on other experience. All right, let's start with primary 3. Based on experience, I know that primary 4, 5, and 6 are more familiar with fractions than primary 3. So why not use word problem here? Something like 4 divided by 2 over 3, you can say to the students, or you write, assuming you have 4 pieces, 4 complete pieces, and you want to share among your friends so that each friend have 2/3 of a single pizza. So how many of your friends will get this 2/3? Something like this. You can twist the question, but let it be in words. So draw on the board 4 pieces. 1, 2, 3, 4 complete pieces. Then because we are taking 2/3, you can divide each piece by 3 equal parts. 3 equal parts. I might be wrong. This is why I am inviting you. All right. You are giving each friend 2/3 of a pizza. So you can share 2/3 because every piece of pizza here is 1/3 because you divided it into 3. So this is 1/3. Together with this one, you have 2/3. Together, this is 3 over 3, making a whole. So give every single friend 2/3. This portion I have shaded. This is 2/3. This is 2/3. This is another 2/3. So how many friends so far? 1, 2, 3, 4. So you have 4. But we still have some portion left. If you take this piece that is left and connect it with this remaining piece, you're going to get another complete 2/3. Another complete 2/3. So you have one friend will take this piece, another friend will take this piece, 2 of them. You see, 2 plus 4 is equal to 6, which means that 4 divided by 2 over 3 is 6. This is how I believe it should be taught in primary 3. Now, what about primary 4? In primary 4, you can start with 1 whole, then you multiply by the rest because this is 4 wholes. Something like how many 2/3 are available in a 1 whole. For example, if I have the same pizza, let me use the same pizza. If you divide it into 3, how many 2/3 can you find here? Remember that each piece here, they are equivalent. They are equal, right? So this is 1 complete 2/3. This region that I have shaded is 1 complete 2/3. So I have 1. Then this region is half of this. It's half of this. Right? It means that in every single whole, you can find 1.5 of these 2/3. But remember, we have 4 wholes, not a single whole. So to get the total, everything here, after simplifying, it will be 4 times 4 of this 1 whole number 1 over 2. And remember that 4 times this, because multiplication is another series of addition, you can take 1, 1.5, plus another 1.5, plus another 1.5, plus another 1.5 in 4 places. 1, 2, 3, 4 is the same thing as 4 times this. All right. Remember, half and half will give you 1. Another half and half will give you 1. So we have 1 here, we have another 1 here. So all together, you can see we have 1, 2, 3, 4, then 5 and 6. It means that if you take 4, you divide by 2 over 3, you're going to get 6, just the way we got 6 here. So in primary 4, we are starting with 1 whole. Then we ask the students how many lots of 2 over 3 is there in 1 complete whole. Whatever you obtain, you multiply by 4 since we have 4 wholes. And what about primary 5? In primary 5, you can tell primary 5 students that Division is another series of subtraction. Why? Because remember, if you have 6 divided by 3, which we believe is equal to 2, is the same thing as removing 3 a multiple times till you get to 0. So let's do that. 6 minus 3, this is equal to 3, right? Then you take that 3 again, subtract 3, you get 0, then you stop. How many times have we removed 3 before we got to 0? 1, 2, which means that 6 divided by 3 is equal to 2. We can do the same thing here. We can determine the number of times we're going to subtract 2 over 3 from 4 till we get to 0. So let's do that. 4 minus 2 over 3 is equal to what? This time this 12 minus 2 is 10, so you have 10 over 3. Take that 10 over 3 again, subtract 2 over 3. This is going to give us 8 over 3, right? Take that 8 over 3 again, subtract 2 over 3. This is going to give us 6 over 3. Remember, if the denominators are the same, you can always subtract or add the numerators. Take that 6 over 3 again, remove 2 over 3. This is going to give us 4 over 3. Do the same thing, 4 over 3 minus 2 over 3. This is going to give us 2 over 3. And finally, 2 over 3 minus 2 over 3 will give us 0. So how many times have we subtracted 2 over 3 before we got to 0? Count. 1, 2, 3, 4, 5, 6. Which means that this is indeed equal to 6. But primary 6, they're a little bit matured compared to these ones. You can tell primary 6 students that dividing a number by any number is the same thing as multiplying that number by the reciprocal of the divisor. Let me come here and explain. If I have 6 divided by 2, I can tell my students in primary 6 that 6 divided by 2 is the same thing as 6 times the reciprocal of 2 is 1 over 2, which means half of 6, right? This is half of 6, which is 3. You can tell primary 6 student the same thing. This is the divisor, right? This is the dividend, and this is the quotient. So you take that 4, change this to multiplication, then flip this one to make it reciprocal. It becomes 3 divided by 2. As simple as that. You can either divide before you multiply or you multiply before you divide, because a whole number will always multiply the numerator of a fraction. So this time this will give us 12, and 12 divided by 2 is 6. Or you divide 4 by 2, you get 2, and 2 times 3 is 6. In either case, you have to get 6. So evaluate me, please.